Okay, well, moving forward with certain questions from energy, especially as related to the field tensor and how to write things out in a four-vector understanding. It is a fair question to assume that we need to have some work done on the physical interpretations of all these mathematically nice, compact things that we have. So let's work on that with this particular question. The statement is, work out and interpret physically the 𝜇=0 component of the electromagnetic force law. What we know about this is that the Minkowski force is Kμ = Q eta nu F mu nu. So let's see how to deal with this and take it step by step. All right, first and foremost, we're interested in what is the zeroth component. So 𝜇 = 0, and then we have Q eta nu 0 nu, which means that we have to sum over all the nus. So the nus go from 0 to 3 as well. So hence Q constant, stay out there. Eta nu, eta 0, 0, 0, eta 1, 0, 1, eta 2, 0, 2, and 3, and 3. And if we reference this, this happens in the first row of the electromagnetic field tensor, so all these components should be positive. Clearly the 0, 0 is 0, so we're not going to worry about the eta components. But what we see here is that we have an eta and an e to the x, eta 2, e to the y, eta 3, e to the z. But we notice that eta 3, 2, and 1, those are all corresponding to x, y, and z too. So after we factor the c out, what we see is that this looks like a dot product between the velocity eta, proper velocity eta, and the electric field. So that's what we write it as. We know, however, that the proper velocity eta is this gamma u, u being the ordinary velocity. So that's one interpretation of it, but what exactly does this mean? Okay, we can kind of see how QE is a force and U dotted with the force gives us the work. So let's see if that is what transpires. But earlier we saw that the zeroth component of the Minkowski force with respect to the momentum four vector, energy momentum four vector, turned out to be 1 over c dw d tau, where w is the energy of the particle, and since d tau is equal to 1 over gamma dt, the proper velocity or proper time and ordinary time, we have 1 over c d tau of ddt, or excuse me, of dw d tau. Plug everything in. What we see is that this zeroth component has to be equal to that, so we set them equal to one another. And we see that once we do that, the gamma c cancels with the gamma c on the right hand side, and we're left with dw dt equal q times u dot e. So what this says is that on the left hand side we have a power, but the power has to be equal to the power delivered to the particle is the force QE times the velocity u, which is how it should be. Again, force dot displacement gives us the power, or excuse me, the work. So if we have a time derivative of that, which is how we get the velocity from the displacement, then we should have the power delivered. So that is all starting to make sense. It all comes together full circle. So I think our physical interpretation of this thing is actually working really well. Sometimes it's just written in a little more weird of a form. But yeah, that being said, I think our time derivatives from classical mechanics and setting things up in that perspective is starting to come back, and we will see more work with this pretty soon.